Hello everyone, I am Karthik from ITA section and my roll number is 2095191230. Today on Oose, my tech talk topic is about the closing the gap between the software engineering and the education and the industrial needs. Let us see what are the situations that are filling the gap between the software engineering, education and the industrial needs, and how we can overcome this situation by learning some techniques and knowing some important things. In further slides, briefly, let us dive into our topic. So let us know the abstract. According to different reports, many recent software engineers graduates often face difficulties when beginning their professional careers due to the misalignment of the skills learnt in their university education with what is needed in industry to address that need. Many studies have been conducted to align software engineering education with industry needs. To synthesize that body of knowledge, we present in this paper a systematic literature review which summarizes the findings of 33 studies in this area. By doing a meta-analysis of all those studies and using data from 12 countries and over 4,000 data points, this study will enable educators and hiring managers to adapt their education hiring efforts to best prepare the software engineering for work. Coming to the introduction, we used the established process for performing systematic literature review. Studies in SE2 and systematically gathered a set of 33 papers on the subject published between 1995 to 2018. Our review aims to identify the most important skills in industry and synthesizing the evidences of knowledge deficiencies in graduating SE students. Our goal in this paper is to shed light on importance and the knowledge gaps of the different SE topics and to ultimately answer the question of how to best train software engineers of tomorrow. By summarizing what we as a community know in this area, our article aims to benefit the readers, both educators and the hiring managers, by providing a big picture on the state of the community with respect to the aligning SE education with the industrial needs, and an index to the body of the knowledge in this area. Let us start with a brief review of our review procedure and then continue with the findings. So the review procedure. The review aimed at the addressing following review questions. Review question 1 is about the what skills are the most important in the software industry. Also, given the fast changing nature of the software engineering, we wanted to know if the most important have changed in the last 5 years. And the question 2 is about, is there evidence of knowledge deficiencies in graduating SC students like software engineering students, and what are the topics with the highest knowledge deficiencies? And coming to the question 3, to what extent are soft skills need important? In addition to the hard skills, we only included the papers which focused on the aligning software engineering education with industrial needs, which are based on the empirical data such as service results on the interview data. So we included the latest criteria to exclude the papers which were based on the pure personal opinions. After compiling an initial pool of the 94 papers, a systematic voting was conducted using the above criteria among the authors, and our final pool included 33 papers. Our research method is meta-analysis, which is the form of a synthesis that combines the quantitative data from the primary studies. The pool of the 33 papers in this work, the purposes of the meta-analysis is to aggregate the results of the primary studies to provide a consolidated big picture on a given data topic. So this is the table 1 listed reviews in the meta-analysis, and their paper titles which are of around 33, which we have mentioned in the before slide. These are the titles, we can search for it and we can see the reviews of those 33 titles. So data from 12 countries and over 4,000 respondents. Most of the papers in the poll had extracted data from one country only. For example, uh, had data from the UK and the uh, The P2, which is the paper title 2, had extracted the data from the UK only, and the P8 to S11 had the data from the USA. The advantage of our meta-analysis is that the combined dataset has data from the 12 countries, which provides a stronger evidence on the subject than each of the single studies. The top countries from which data were gathered are USA, Canada, South Africa, New Zealand, and Spain. Each of the following countries was represented in one paper each. And UK, Norway, Philippines, and Jordan, Australia, Finland, and Somalia. Two papers had data from both USA and Canada, and one paper surveyed data from worldwide scale. Also, in terms of number of data points, studies had between 8 to P28 and 600 respondents. Since the studies were mostly conducted in different countries, there is a slim chance that the single software engineer had participated in one more than one study in the pool. Thus, when we add up the number of respondents all over the 33 studies, we can say that the data and the evidence are from up to 4,132 respondents. The most important skills in the industries, which is the question one which have asked by the users. So let us see the answer for this. Comparison of the two charts in the figure 1 provides the interesting insights. When looking at the all papers, requirements, design and the testing are the most important, also most frequently mentioned topics with the software engineering professional practice, project management and the development coming next. However, when looking at the recent papers, the top three topics change to SC professional practice, project management, and the testing. This seems to be the denote that the less technical skills such as the software engineering professional practice and the project management have become even more important in software engineering education in recent years. Software engineering professional practice covers topics such as the professionalism, group dynamics, and the communication skills. And there are soft skills especially required in modern agile software a development that is more strongly based on the communication and the interaction that traditional waterfall approaches. So according to our experience, an effective approach to cover the project management and the software engineering professional practice is our education practice is by larger software engineering projects done by the students teams either in class or even together with the companies. So this is figure 1 which shows the statistics of the uh, given questions. The most important skills are data from all the papers versus papers in the last 5 years. So this is the uh, importance of the important skills in the software engineering. Knowledge gap and highlighting the topics that we could teach more, which is the required question 2 and the review question. So 8 of the 33 studies also measured in quantitative terms the knowledge gap from their survey participants, which is usually done by subtracting the importance in a job measure of a given essay topic from the measure of how much the participant had learned during her or his university education. We extracted all the quantitative and knowledge gap values and calculated their normalized average. We show in figure 2 a scatter plot to visualize the average knowledge gap values versus their importance. The x-axis shows the average importance and the y-axis shows the average knowledge gap. So as we see in the case of all 8 papers, generally speaking, the two factors are quite correlated and which increases the reported importance. More knowledgeable gap has also been reported. The greatest reported knowledge gaps are in the following: configuration management, software engineering models and the methods, and software engineering process design and testing. Thus, in general, more education and training focus shall be given to the topics by university programs also when training newly hired staff in the industry. We have also divided the scatter scatter plot of the figure in 2 into 4 quadrants to be able to clearly see the software engineering topics with low and high importance and the low and high knowledge gap. So, coming to the required question 3, review question, it is widely discussed hard skills alone are not enough. Have you got soft skills? It is widely discussed in the community that hard skills alone do not make a great software engineer, and also soft skills are also equally important, if not more. And hard skills are comprised of a domain knowledge and the technical skills, while soft skills are comprised of the team and the interpersonal skills. So, soft skills contribute significantly to individual learning, team performance, and the client relations and the awareness of the business context. So, 24 of the 33 studies recognize the importance of the soft skills. We categorize the soft skills as the follows: teamwork and the communication skills. We categorize soft skills as the teamwork and the communication skills and the leaderships and the critical thinking and others. Many other important soft skills were also mentioned in the paper, such as the cultural fit, and understand business drivers, aptitude and the attitude, and the coping with the ambiguity, learning and curiosity, passion and drive to the innovative, etc. So other interesting findings we have observed are a lot of other interesting findings when reviewing the papers. For example, there were suggestions on decreasing the emphasis on the certain topics in software engineering university education. That is what we should teach less. And the paper one, which shows the express that the participants felt that their university education gave them a much better grounding in mathematics than in a software topics, and thus recommended that emphasis on the certain mathematics topics should be changed and decreased. The empirical data also showed that much mathematics in is being forgotten, whereas much new software knowledge is being acquired on the job. So also reported that there is a over emphasis in mathematical topics and under emphasis on business topics in software education. So called for less educational focus on phrasing and compiler design, formal specification methods, digital electronics, and the digital logic in software programming. So implications and the road ahead. The findings presented in this article shows the importance of the software engineering professionals practice and the soft skills in the general. The importance of the certain software engineering activities and the skills in the software engineering education, knowledge gaps in the specific areas of software engineering, and the importance of the real world examples in a software engineering courses. The authors have already started to benefit from the findings of the presented review and the meta-analysis during their study in their SC education activities in several ways. These reviews helped us to identify the most important software engineering topics based on the largest synthesized body of the evidence in literature. So also we found that the greatest knowledge gaps are configuration management, SC models, and the SC process design and test testing. This is about our topic, and thank you.